Good afternoon, sir. My name is Tan Kai-shen. We are from Group 22. Our topic is Agriculture Farm Monitoring System. So now I would like to show the introduction. As we all know, agriculture is an important sector to produce the food. So the main problem in this sector was high labor requirement. Besides that, the pest detection is also very hard. So in the current technology, farmer had applied IoT sensor to collect data and weather prediction. Besides that, farmer had also applied drone to spread the fertilizer. So in our project, objectives are to improve the pest detection and also farm monitoring. So now I would like to pass to next presenter. Thank you.
Hello, sir. Next, I'll be talking about the problem statement. So these are the three issues that can affect the crop or agricultural output. First, climate change in experienced farmers as well as pest infestation. So these are the problems that we aim to solve by using the system. Next, objective and proposed solution. So these are the objective or the proposed solution that we use in order to solve the problems stated in the previous chapter. First, it is to develop a system that allows the farmers to effectively and efficiently monitor the condition of the farm. For example, the farmer is able to know, such as on day 1, what is the humidity level, on day 2, what is the humidity level, let's say 23% on day 1, 24% on day 2. They can also know when, where, how is the pest infesting the farm, such as on month 1, 23 pests has been discovered in their farm, on month 2, 24, something like that. Next is to allow the farmers to be notified upon discovering any critical situation on the farm. For example, if the humidity level has exceeded the threshold, such as humidity level discovered on this period of time has exceeded 40%, let's say, then the farmers will be notified. Hello, sir. Next, I'll be talking about the architecture diagram of the proposed solution. So this is the overall architecture diagram of our system, as you can see. Next, I'll be talking about each part individually. So first of all, IoT call to SNS. This is used when the data being sent to IoT call exceeds a certain threshold value. For example, temperature value exceeds is below than 20 degrees Celsius. Then it will use NS to send email verification to user. Next, IoT call to IoT sensor to Lambda to DynamoDB. This is a data flow used to send IoT sensor data to DynamoDB. So the flow is that the IoT sensor data sent to IoT call, then it will send this data to IoT sensor to Lambda for pre-processing before sending it to DynamoDB. The next one, DynamoDB to DB to S3 using CloudWatch event to S3. This is to send data from DynamoDB to S3. CloudWatch event is used to routinely trigger this function which will get data from DB and send it to S3. Then S3 to S3 to Lambda using recognition to SNS and DynamoDB. This is the function used to do pest detection. When image is sent to S3, it will trigger this Lambda function which will use recognition to detect if it is the pest. If it is, then we will do SNS email notification to user as well as store this information in DynamoDB. Next, S3 QuickSight. This is QuickSight will use the data from S3 in order to display all this data in a dashboard manner for the farmers to view it intuitively. The next one, Cognito pre-sign-up. This Lambda function is used to enable the Cognito so that the Cognito will not have to do email verification for every new user sign up. Lastly, API gateway retrieve data S3. So you know, API gateway is used to generate API, and the endpoint of this API is retrieve data. So the API will call this retrieve data, which will get data from S3 and send it back to the farmer, the user itself. So that's all for architecture diagram. Thank you.
Hi, my name is Lim Hui Ying. Now I will talk about the study of different IoT platforms. One of the popular IoT platforms is AWS IoT. AWS IoT is a managed cloud service platform which allows the connected devices to communicate with AWS cloud applications and other devices securely. It can handle up to billions of devices and messages due to its robust, scalable, and secure infrastructure. Next, Microsoft Azure IoT is another popular IoT platform in the market. Azure IoT is a collection of cloud services managed by Microsoft for connecting, monitoring, and controlling billions of IoT devices. The benefits of using Azure IoT includes simplicity, flexible pricing, and strong security. Besides that, Azure IoT platform is very user-friendly and simple for people of all skill levels. That's all from me. I will pass to my groupmate to talk about Google Cloud IoT.
My name is Chu Zhuozun. Now I want to talk about Google Cloud IoT. Google is the most popular search engine for people around the world. So Google offer a lot of cloud services, include IoT. And this Google Cloud IoT, it provide a lot of tools such as data flow, sub IoT core, and so on. So all this IoT, it helps to predict which equipment need maintenance and help to optimize their performance. It also helps to ensure real-time tracking by helping all users to collect the data during the real time. So what are the comparison between these three cloud services in terms of their IoT? So Amazon Web Service, it mainly provide a lot of services and it was easy to use, scalable and flexible compared to other two. And the IoT services that it provide is diverse, but it's not specialized. However, for Azure, it provides full and complete IoT services. It was easier to use and adopted, and it also offers mostly industrial service, which AWS and GCP lack. Whereas for GCP, it's more focused on artificial intelligence and machine learning, and it provides really less IoT related services. However, it is also focused more on the IT company service.
So now I would like to continue to present the future work. So the future work in this project is to make the improvement to monitor fruit tree farm. So the first improvement will be fruit ripeness detection. So this detection will help to detect the hormone released by the fruit tree called ethylene, because this ethylene can help to promote the ripening of fruits. So besides that, we can also have the variable rate application as known as VRA. VRA can help to place the high-end sensor of fruit tree to detect the tree's properties such as height of tree and also weight of the tree. So this will help the farmer to predict the required fertilizer amount in every tree. So that's all for our presentation. Thank you.
So first of all, I've created a topic called humidity sensor. Same goes as other like soil pH temperature. So in this case, I'm using humidity sensor as my example. So I have also created a subscription using my Utah email. So after the data exceed the threshold, it will send to my Utah email. So now we will go to the IoT rule there, and then you come to the act there, and then click the rules. And then you come to the, I've created a rule called humidity warning. Then remember to enable it. And then in this part, I've put a SQL statement that if the data is less than 45 or more than 55, then it will alert the user using the email, send a message as an SNS push notification. So we will see how this thing works. So I've created a programming statement that state that this statement means that you will create a random value between 20 to 70 for my data. So I will open a command prompt using Ctrl+Shift+C, then change my directory to this part, then to my main file, and then so now my IoT core will send the data. So my data is 22 for my humidity sensor. So we have seen that my humidity data is less than 45, so it will trigger the email to my Utah email. So that's it. It trigger the warning reply to my Utah email.
Now I will show how the data flow from IoT core to DynamoDB. First of all, a table called IoT sensor is created to store the data of the IoT sensors. Then at the Lambda console, we have created a function called IoT sensor to Lambda. The trigger of this function is the AWS IoT sensors. This code will import the data from the IoT core to the DynamoDB table, which is the IoT sensor table. Then we can do the testing using this JavaScript code. Run this code to simulate the data being sent from the sensor. Take note of the data being sent. After that, go to the IoT sensor table to check the result. So it is noticed that the sensor data has been added to this table.
Hello sir, next I'll be talking about the AWS console part for data flow from DynamoDB to S3. So this is the Lambda function we use to get data from DynamoDB and send it to S3, and it is triggered by CloudWatch event. So this is the CloudWatch event rule that trigger the Lambda function. Every 1 minute it will trigger DB to S3 for testing purpose, which is this one. And these are the coding inside the Lambda function. The table name for the DynamoDB is IoT sensor, and the place where the bucket name of the S3 is lambda put S3, and it is sent to this folder name, and these are the code we use to send it. As you can see here there are the data items in IoT sensor, and this is the place where the data is sent. As you can see here, so this is the one. We can try to download and see it. So, as can be seen here, there should be a total of 39. So 39. That's all for this part. Thank you, sir.
For this project, we have implemented the Amazon Recognition custom labels to detect pests from images captured in the agricultural farm. The project called Pest Detection is created. We created the dataset of the pest images and put labels on all the images to identify the pests. Then we began to train the model using the dataset. After the training is completed, we can start to use the model by clicking the Start. Once the model is started, we can do the testing using this Python code. Run this code to upload an image file to the specified S3 bucket. This is the image file being uploaded. Uploading an image file to the S3 bucket will trigger the Lambda function called S3 to Lambda. The code here will get the label for images uploaded to the S3 bucket, and it will send the result to the email using the SNS publish method and also to the IoT sensor table. So now we can go to check the email and table. It is noticed that an email of the pest detected is received. A new record is also added to the IoT sensor table.
So now I will continue to present the quick site service and also the connector service. Because we go to the quick site service, we need to put the manifest file from the S3. So we click lambda put S3 bucket, and then we click IoT sensor. So we can see export.csv and export.json is here. So we click export.json, and then we can see the URI of the export.csv is in the JSON. So we open the dashboard and then create a new data set. We click S3, and then we can see we need to upload a manifest file. So we just copy the URI of the S3 export.json to create the data set. And then we can, after we created, we can see at the data set. And then this is we have created. And then after we do at the analysis, and then after we do the graph in the analysis, we can publish to the dashboard. So this is the graph we have published as a dashboard in a quick site. So we have the pest detected and then also the statistic of sensors. So we move to the connector. So in the connector, we have created the user pool. So in the user pool, we can see how many users have been signed up. So we have also triggered a Lambda function, which is the pre-sign up Lambda trigger. And then this function will help to the email auto verification by the system. And then so that user no need to do the verification of email again. So we go to test the user connector. So we open the app integration tab, and then we click client 1, and then we click view hosted UI. So this will lead to the page here. Okay, so we click sign up. So we type in the username, an email, and then also the password, and then we click sign out. So this will lead to the API gateway, and then this will be the another function. So that's all from the presentation. I will pass to next presenter. Thank you.
Hello sir, lastly I'll be talking about the API gateway. So this is the Lambda function, which is the endpoint of this API gateway, which will retrieve data from this retrieve data Lambda function. So they returns the data, which is the part where we want. And this is the API gateway, the invoke URL used to invoke this API. Upon invoking this API, it needs to be authorized by the Cognito's access token. For example, here, this is an example of Cognito, and the access token can be gotten from the link, which is seen here, the access token part. And I send it out, and this is the part used. So I'm using Postman for testing. So as can be seen, the header here, this is the access token, and upon sending the request, and this is the result we gotten inside the body, which is the value that is from the Lambda function. So that's all for our presentation. Thank you, sir.